Hi, everybody. This is Toto here. Dorothy's sitting over on the couch. Coming at you from my living room. I wanted to go over the second half of the Section 6.1 handout from yesterday. We covered the first half towards the end of class. We converted the percentages to probabilities by just making these like 0.42, 0.34, 0.15, 0.08, and zero point zero 0.01. And then we made bar graphs for sorry. We made bar graphs where the bars were kind of smushed together. Those are called histograms, where the heights of the bars were the probabilities, and the width of the bars were all one. They stretched halfway to the left and halfway to the right, about the horizontal axis, which had 0, 1, 2, 3, and 4 on it. There's a PDF right above this, probably, so you should be able to see that. Okay, so side 2. So I downloaded that down here. So I wanted to look at the second side of this. The second side says the College Student Senate is sponsoring a spring break Caribbean cruise raffle. The proceeds are to be donated to the Samaritan Center for the Homeless. A local travel agency donated the cruise valued at $2,000. The students sold this many tickets, 2,357, at $5 per ticket. Kevin bought 16 tickets. What is the probability that Kevin will win the spring break cruise? So the probability that Kevin wins, we'll say that's the probability of a Kev win. That's going to be the wins divided by the ways, right? So they're going to pull a ticket at random. The denominator should be the total number of tickets that were sold. So 2, 3, 5, 7. And then the numerator should be the number of tickets that make Kev win. So he bought 16 tickets. So the probability of a Kev win is going to be 16 divided by 2,357. On the other hand, what's the probability that Kevin will not win? Well, we could use the rule for complements. This probability of a Kev lose. That's going to be 1 minus 16 divided by 2,357. Since Kevin losing is the complement of Kevin winning. So another way to write that is to rewrite 1 with a denominator of 2,357. So that'd be 2,357 divided by 2,357 minus 16 divided by 2,357 for a grand total of 2,341, I think. 2,341 divided by 2,357. When we have a fraction where the denominators are the same and we want to add or subtract, we just add or subtract the numerators. The denominator stays static. All right, part C. Expected earnings can be found by multiplying the values of the cruise. The value of the cruise by the probability that Kevin will win. What are his expected earnings? So his expected earnings, they tell us the problem, are the probability of a Kev win times multiplying the value of the cruise by the probability that he wins. So the cruise, they say, is worth $2,000. So this is going to be 16 divided by 2,357 times 2,000. It'd be more appealing to work with decimals at this point. Let me grab my phone over here. Let's see, 16 divided by 2,357 as a decimal is like 0.00678829. And if I multiply that by 2,000, I get $13.58. All right. Is this more or less than the amount Kevin paid for the 16 tickets? I don't know. How much did he pay for 16 tickets? Let's go back to the question. Local travel agency donated the cruise, valued at $2,000. The students stole 2,357 raffle tickets at $5 per ticket. Kevin bought 16 tickets, so they're $5 each. Kevin bought 16, so I'd say that he paid whatever 16 tickets times $5. So that's going to be, excuse me, Toto, $80. How much did Kevin effectively contribute to the Samaritan Center for the Homeless? So this goes in line with my logic on 50-50 raffles. I don't know if you guys have ever been at like a charity event. They do a 50-50 raffle. There's some part of your purchase that is selfish. It's how much you expect to earn. And the rest is your contribution. So basically, however much you pay, get off the keyboard, but however much you pay is half of that is selfish and half of that is coming back to you in a 50-50 raffle. Let's look at this situation. So his effective contribution is going to be how much is selfish. So his selfish is going to be the $80. Sorry, not the $80. The $13.58. That's how much he expects to win. And then he paid $80. So to find out his effective contribution, you subtract the selfish off of what he paid. So the effective contribution, the amount that the Good Samaritans or whatever it is going to be 80 minus 13.58, which is, I think, hard to subtract with a cat on your lap, $66.42. All right. So if y'all got any questions, hit me with help requests or hit me with some emails. Hope y'all have a great week. I'll be posting a quiz at some point for just section 6.1. It'll probably be a short one. All right. Talk to you later.